There's more intelligence in your house cat or your dog than there is in the smartest AI system in existence today.
We've heard Elon say that we'll be in world of abundance, which I think we already are. Then how does one think through fulfillment from work and keeping themselves alive through health?
As a scientist and an engineer, I've thought that the best way to discover the mysteries of intelligence is to build an intelligent machine, because that's the only way you can figure out what are the necessary, what we now call machine learning. It wasn't called that way at the time. And some of the pioneers were people like Widrow at Stanford, right?
I've been very blessed and privileged to be with him.
In my career, I've seen like 3 or 4 generations of, new paradigms appearing in AI, and people claiming, oh, within 10 years we'll have machines that are as smart as humans. And every time it was false, because it's just harder than you think it is. And there was similar hype that we see today of, well, now we have LLMs, within 10 years we'll have super intelligent machines. I mean, some people even say within 2 years, which is insane. There's different types of AI systems, right? There are AI systems that are, trained to understand images or things like that. And then there is the, LLMs and chatbots that we're used to. Their design, it really works well for when you apply them to sequences of discrete symbols, and that's what human language is, right? And sequences of words. The real world is way more complicated than language.
So why have this story and this narrative? What does it do?
Well, so I'm sort of trying to warn people, like, the stuff that...
In this video, I'm in conversation with Yann LeCun, who's the founder of AMI Labs, a former chief AI scientist at Meta, a Turing recipient for deep learning with Jeff Hinton. We talk about artificial intelligence, get into some of its history, the hype, where LLMs fall short, and some of the other AI systems in Yann's lens. We also bring about the contributions of my Stanford professor, Dr. Widrow, who Yann considers as one of the pioneers in this field, and so do I. We also talk about aligning the work and fulfillment. I hope you find value in this conversation. This is Nitin Dua, serving you with love.
So here I am today with Yann, and we were just talking about my professor, Widrow, who we unfortunately lost. And he gave me the exposure to cognitive AI back in the day with ANNs. He's also somebody that Yann has been speaking to at Stanford and known for several years. But today, we want to talk about how he has a terrific career. He's a Turing Award winner, has spent a lot of time at Meta, leading the AI initiatives. He's also a professor, spent 2 decades plus doing that, and is one of the leading voices in AI, and has tremendous skills, tremendous agency, has been doing phenomenally different initiatives. And I got an opportunity that I'm very privileged to sit down with him and learn how he thinks about work that fulfills the career that he's transitioned and continues to sort of play different roles, and the role of health and mind in all of this, and where we are headed. We've heard Elon say that we'll be in world of abundance, which I think we already are. Then how does one think through fulfillment from work and keeping themselves alive through health is something that I want to get your perspective on, Yann. Thank you for making the time.
All right, thank you for having me on.
Yeah.
So I don't have any, magic bullet or any trick or anything. What has motivated me my entire life pretty much is solving scientific questions. And one of the big scientific questions of our times is, what is intelligence? How does the brain work? The human brain is one of the most complex self-contained systems that we know about, and figuring out how it works, I think, is one of the most interesting scientific questions you can ask, along with, what's life all about and what's the universe made of, right? So I've been fascinated by all 3 of those questions, but as a scientist and an engineer, I've thought that the best way to discover the mysteries of intelligence is to build an intelligent machine, because that's the only way you can figure out what are the necessary principles and details to make, that are necessary to intelligence. So from the start, when I was still an undergrad, figured out that maybe I was too lazy, or, I didn't think I was smart enough to, and I didn't think other people were smart enough either to conceive an intelligent machine.
Okay.
And that intelligent machine should build itself, right? So hence the idea of learning. And I discovered when I was still an undergrad that there were like a whole movement in AI that had disappeared at the time. We're talking, 1980, 81. of people who were working on what we now call machine learning. It wasn't called that way at the time. And some of the pioneers were people like Bernie Widrow at Stanford, right? Which
I've been very blessed and privileged to be with him.
right, his years. So it's an interesting story about him. So he came up with a learning algorithm for what we now call linear classifiers, or what we would now call a single layer neural net, like a shadow neural net.
So back in the day of LMS and
LMS, so this was 1960, 61. And before that, there was the perceptron, which was sort of a rival learning technique, basically, for the same architectures. And those systems were really limited in their capacity. Yet at the time, there was a similar hype that there is now with AI, where people said, oh, now that we have a way for getting machines to learn, maybe within 10 years, we'll have machines that are super intelligent. Of course, I was wrong, but they didn't know, right? And there was similar hype that we see today of, well, now we have LLMs, within 10 years, we'll have super intelligent machines. I mean, some people even say within 2 years, which is insane. So, well, my thought is that in my career, I've seen like 3 or 4 generations of, new paradigms appearing in AI, and people claiming, oh, within 10 years, we'll have machines that are as smart as humans. And every time it was false, because it's just harder than you think it is. So, and there are limitations you don't see right away, right?
you don't see what you don't see.
So here's an interesting tidbit. When at the end of the 60s, people realized that the techniques they had, like LMS and perceptron, were limited. And there was this book published by Minsky and Papert on the limitation of perceptrons and linear classifiers. And so people abandoned the idea of using those techniques to build intelligent machines, right? But what they did is that they just changed the name of what they were doing. So Bernie Widrow renamed what he was doing as adaptive filters. And he basically completely jump-started the whole field, which is a whole subfield of engineering, of adaptive filtering, which is incredibly successful in the sense that we would not have digital communication and cell phones and stuff like that without.
Yes, absolutely. I remember the necklace that he built early on,
right,
for hearing,
yeah,
which had adaptive filters.
Exactly. And echo cancellation for video communication and all that stuff. That's all based on stuff that was developed in the 1960s, in part by Bernie and the student followers, right, and students. And so, and you've seen this happen over the course of history, where people had the ambition of building intelligent machines, and when they realized it was too limited, they kind of renormalized their ambition and then renamed the field.
Our team requested to share this with you. Our data suggests that many of you who have been watching our videos have still not subscribed. Some of you have reached out to me to know when the next video comes out. May I request you to please subscribe and hit the bell icon so you can get notified when the next video goes out. By subscribing, you also become part of our mission, empowering professionals, helping progress in the careers, integrating health and mind and fulfillment. Please share this with someone who may find value in this.
Another branch of what Bernie started in the 60s was called statistical pattern recognition.
Yes.
There was another branch of adaptive filtering, and so that becomes, it sounds much more serious if you talk about adaptive filters or statistical pattern recognition, as opposed to neural nets and intelligent machines based on
But it's essentially the same.
It's the same thing.
Yeah.
I mean, a little more mathematics and formal analysis, but it's really the same motivation.
So why have this story and this narrative? Well, what does it do?
Well, so I'm sort of trying to warn people, like, the stuff that there's been a similar phenomenon in the 1980s, where there was like a huge amount of hype around expert systems. Like the coolest job in the world was going to be knowledge engineer. You were going to sit next to experts and then translate the expert knowledge into rules and facts. And then now the expert knowledge would be, in a computer, and you could, use the computer to kind of replace the expert, basically, right? And huge amount of interest in this in the early 80s. Japan started a huge national program on 5th generation computer, around this idea. Some good things came out of that, but And there was kind of a small industry around this, but it was largely a failure in the program to kind of build real intelligent machines and constructing a whole industry around it. And it was kind of a crash of an AI bubble, if you want, in the late 80s or early 90s. So those things have happened before, and people just forget because they're too young. Right? So, I mean, I'm not saying you should not be young. I'm just saying like you should learn history and then realize we are just repeating history. Now,
I'm a great teacher. I mean, yeah, absolutely. Please go ahead.
I'm still an optimist. So, I think AI is going to make a lot of progress. And eventually we're going to get to, intelligent machines that have the same level of intelligence as humans, but it's not going to be with LLMs or just scaling them up or whatever, right?
What do you think it will be?
Well, so, I spent the last 5 years trying to sort of explain that to everyone in every one of my public interventions.
Who has not followed your work, but if you can simplify what's the gist of it and why should they really understand it?
So there's different types of AI systems, right? There are AI systems that are, trained to, for example, understand images or things like that, or specialized to predict the conformation of proteins or do all kinds of stuff on this side. Those are relatively specialized. And then there is the, LLMs and chatbots that we're used to. Those are specifically, their design really works well for when you apply them to sequences of discrete symbols, and that's what human language is, right? And sequences of words. So they work well for this kind of signal because it turns out this kind of signal is simple. They're trained to predict the word that follows a sequence of words, and that turns out to be relatively simple if you have, enough compute power, enough data to train the system, enough memory. You can never predict exactly which word follows a sequence of words, but you can predict basically a probability distribution of all possible words in your dictionary. And from that, you get kind of useful systems that generate text. Now, however, if you want to use the same kind of trick to get a system to understand the real world, it doesn't work. The real world is way more complicated than language. We tend to think as humans that, human language is sort of the epitome of intelligence. No, language is simple. The real world is really what's complicated. There's more intelligence in your house cat or your dog than there is in the smartest AI system in existence today. Those AI systems can, have accumulated a lot of factual knowledge, but they're not very smart. They're knowledgeable, they're not smart. And so the thing I've been working on is how do you get an AI system to learn how the real world works, mostly by observation, about, watching the world go by.
Absolutely.
And that turns out to be much more challenging than predicting the next word in a text.
It's like fitting in a box, but you don't know what you don't know, as you were discussing, right? And it's not translated yet to observability.
Well, in concrete terms, as I told you, you can predict a probability distribution over all possible words that follow a particular text. But if you want to apply the same principle to predicting what's going to happen in a video, right? With the hope that if a system can predict what's going to happen in a video, it will have learned, a lot about how the world works. The fact that, there are animate and inanimate objects, the fact that if an object is not supported, it falls because of gravity.
You were just showing the example of the spoon falling down.
Exactly.
Which you would not have guessed otherwise.
Right.
Yeah.
The problem is there is an infinite number of plausible futures of a particular video segment, and we don't know how to represent usefully a probability distribution over all those plausible outcomes.
Yes.
And so the generative approach to AI of predicting what happens next in all the details doesn't work when you apply it to video. It works to some extent. You can generate cute videos, which is what the video generation systems do, but they don't actually capture the underlying structure of the world. And so for that, you have to use a different set of techniques, which are called JEPA, Joint Embedding Predictive Architecture. That's sort of non-generative architecture. The basic idea of this is you train a system not to predict every details of what happened in the video, but to learn an abstract representation of video and make predictions in that abstract representation space. And that's a key concept which deviates from generative AI. So that's what I've been working on, and it's working really well for text on video.
No, it's fascinating what you describe, and then there is so much still to unravel, uncover, unleash in the years to come. I'm really looking forward to what science can bring. But having done all of that, you also brought in I know like you grew up in France and you also studied there initially and then made the transition to US. You spoke something in between where you said you initially felt you're not smart and you felt others also were not smart in that sense. So,
well, there's a lot of people who are way smarter than me. If I can find them, I hire them either as collaborators or students.
no, absolutely. But just want to go deeper on that. There is also this thought that, I come across executives who are terrifically smart, but also come to a point where they feel they're not good enough in what they're doing. Has that happened to you? Maybe not now, but at some
Every time.
Every time.
Yeah, I've been working with